Hello, everyone. I just wanted to cover a separate method for us to go over section 12.4 with our multiple linear regression, as some students are not able to utilize Excel to be able to install that add-on. So let's discuss other ways that we can do this. But first, I just wanted to mention sometimes on these questions, instead of given data that we can plug in directly, we get the output of our data classified in an ANOVA table, which is an analysis of variance table. So I just wanted to cover an example with that first here. So this says, based on the ANOVA table given, so this we plug it in and this is the output that it gives us, is there enough evidence at the 0.05 level of significance to conclude that the linear relationship between the independent variables and the dependent variable is statistically significant? So for that, all that we're going to do in our ANOVA table is just look at our significance F here and compare that with our alpha. So here our significance is 0.006, which is less than this, so that tells us that it is in fact statistically significant. Okay, so that's what we're looking for with something like that. Okay, now what are other examples of what it will look like, say, if we are working on these analysis of variance or just multi multivariable linear analysis. So I just want to cover again an example where they give us an output, and then I just want to mention how we can go about answering this. So again, I'm just going to copy this directly out of the homework. All right, it says the following table was generated from a sample of 10 junior high school graduates regarding the average number of hours they are supervised per night, the average number of hours they play games per night, and their final grades in the math class. The dependent variable is the final grade. The first independent variable is the number of hours unsupervised each night. The second independent variable is the number of hours of video games each night. So it says write the multiple linear regression equation for it. All this means here is we'll just put the coefficient here. So this would be our 56 point, and then it says round to 3 decimal places, so 0.93 plus, then here it will be our next variable, 6.238, and then 1.994. Okay, so again, this is the output of what we get is given to us here. So for some of these, they're just saying, hey, I'm going to give you the output. Okay. And then you're just going to plug it in. Now, what happens if we're given something a little different? So I want to take a look at this one here. All right. So it says the following data was collected to explore how the number of square feet in a house, the number of bedrooms, and the age of the house affect the selling price of the house. The dependent variable is the selling price of the house, the first independent variable, and so on and so forth. Now, what I can do with this is I can click copy data from the problems. Now I have the data. Then what I'll do is I'll go to this Stats Kingdom website here. So again, this Stats Kingdom website is this here. Let me see if I can make that a little larger for everybody here. All right. So it's statskingdom.com/410multi_linear_regression.html. Or you can just Google multi-linear regression calculator and it'll be this one. Now for these, what we want to do, our first thing is we want to switch our iterations from automatically to manually. What this is doing is if it's set to automatically, if a variable is not significant, it will automatically exclude it and then calculate our new equation based on only those that are significant. That's not what we're wanting to do here. We're wanting to say, hey, just what is it independent of whether or not it is significant or not, and then go from there. So just switch this iterations to manually. Then I'm going to go here, enter raw data from Excel, and I will paste the data that I've copied. Now here, you'll note that it gives me these labels. I'm going to go ahead and delete these labels and delete this row so that my first row is my data here. Then what I'll do is click calculate. Now, you'll note that, hey, I didn't have my results down here. That's okay, just click calculate again. Then here, this is your new equation for these multiple variables. Okay, so this is what we're going to be utilizing here. Additionally, you'll note that it gives us this ANOVA table. And if we take a look for each of these, it gives us the associated p-value, which we can use to determine whether or not it is significant. Okay, so the first question that they ask of you is find the p-value here. So that will just be your overall p-value that you find in your ANOVA table. Okay, so I can just take that and then it says to round to 4 decimal places. So I'll just do that 0.4955. And then our next part here, I just want to show what this looks like. This is one of the easiest ways that students mess up is this one here. So it says determine if a statistically significant linear relationship exists between the independent and dependent variables at the 0.01 level of significance. If the relationship is statistically significant, identify the multiple linear regression equation that best fits the data, rounding your answer to 3 decimal places. Otherwise, indicate there is not enough evidence. What a lot of students do is they will just say, well, it pops out this equation here, so I'm just going to start writing. And then they'll say, all right, this is 6, 5, 4, and so on, and write all of this in, and then hit enter, and it will be wrong because, do note there is this option here. There is not enough evidence. So what we do is compare this p-value to our alpha. Note that this p-value is much greater than this alpha, so the probability that this would be significant is nowhere near enough. Okay, so this p-value is greater than our alpha, so it is not significant, so there is not sufficient evidence. Okay, if there is sufficient evidence, then you will plug it in here, where this is your coefficient, or rather this is your constant. It's this first number here. Then this is your coefficient for your first variable, and so on. Okay, so if they are asking you, is there enough evidence or not, double check that you see, compare that p-value and see whether it works. They might ask also, are any of these variables significant? In which case, compare those individual p-values. But that's the overall idea. So we go to our Stats Kingdom multiple linear regression calculator, switch this iterations from automatically to manually, then enter raw data from Excel, paste, make sure that when you paste, as I did here, it's going to give you this junk that we don't need that are labels, delete it, but then don't just leave that blank. Make sure to delete that next row as well, so that we just have our first bit of data corresponds with the data that we had here. Okay, then click calculate. If it doesn't give you everything straight away, click calculate again and it will input it, or it will output it for you. Okay. But that's all I wanted to mention for this section. So if you do not want to utilize the method that is discussed in the other video, which utilizes Excel, that's okay. You can utilize this. This will be available to you on the exam. I have whitelisted this website to be available for you. But yeah, let me know if you have any questions while you're working. Otherwise, thank you so much for your hard work, and I will see you in the next video.